Okay, here we go now. In this particular section, we're trying to find out how you determine if lines are parallel. All right, so last week we talked about lines, and now we're going to talk about how you determine whether two lines are parallel. All right, now in the figure, well, I think it was Thursday, we talked about corresponding angles. We talked about alternate interior. We talked about alternate exterior. And we talked about consecutive interior angles. All right? And what has to be true. So we said that corresponding angle is a postulate. Listen carefully. If corresponding angles are congruent, the lines are parallel. That is a postulate. All right? Everything else is going to be considered a what? Theorem, because we can prove it. As I tried to tell you, I thought it was a little weird that you're going to prove that alternate interior angles are congruent by using the corresponding angle postulate. So bear with me on this. All right? So again, corresponding angles are congruent, the lines are parallel. Alternate interior angles, if they are congruent, the lines are parallel. Alternate exterior angles, if they are congruent, the lines are parallel. And finally, if consecutive interior angles are supplementary, then the lines are parallel. That's what we're looking at. So we're going to look real quick at questions 1, 2, 3, and 4. All right? If we're looking at question number 1, if angle 1 is congruent to angle 3, I want to look at my figure. Angle 1 and angle 3. First of all, tell me what their relationship is. They are considered what? They are considered corresponding. Yes. And the reason why we're considering them corresponding is because they're on the left side and they're on top of the transversal. So they're considered corresponding. So if they are congruent, what two lines are parallel? Yeah, for some reason, some kids find this a little troubling, so I want to show you real quick. Angle 1 is made up of this angle, and 3 is made up of this. I have mentioned nothing about M, right? Nothing about M. Therefore, J and K are the two lines that must be what? Must be parallel. All right? So here we go. You would say J is parallel to K. That's it. That's all you have to do. And now, those are considered what type of angles, though? Yes. So you would write down J is parallel to K by corresponding angle, and that would be a postulate. Corresponding angle postulate. All right, now we're going to identify angle 2 and angle 5. So let's find angle 2 and 5. So here is angle 2, and here is angle 5. What are those relationships? They are alternate interior angles. So they are alternate interior angles. So if they are congruent, the lines are parallel. But the problem is, what parallel lines are we talking about? J and K. Now, if you thought it was L and M, it's kind of the same principle. Here's J, if this is angle 2, and then this is referring to angle 5. You see how M has nothing to do with that? Everybody see how M has nothing to do with that? Therefore, you would say J is parallel to K. All right? Now, let's try to find angle 3 and angle 10. All right? Oh, and again, those are alternate interior angle theorem. It's the theorem. And I think we're going to end up proving that in a few minutes, so it'll be real easy. Now, let's identify 3 and 10. So here's 3, and here's 10. So those are considered what type of angles? Those are considered alternate exterior angles. So if those are the alternate exterior angles, that would be considered a theorem, alternate exterior angle theorem. So what two lines are parallel? L and M are parallel. Everybody see, it is very easy. All right, it's very easy. All right, now let's highlight 6 and 8. All right, so again, I'm going to find 6 and 8. So here's 6, and here's 8. All right, what are those two angles called? Yeah, they are supplementary, but what type? What's their relationship? Definitely not corresponding. Consecutive interior angles. All right, consecutive interior angles. All right, and if they are consecutive, the consecutive interior, now notice one is acute and one is obtuse. Does everybody agree with that? Since one is acute and one's obtuse, they must be supplementary. All right, so that is the consecutive interior angle postulate. If the two angles are supplementary, then the two lines are parallel. What two lines are we talking about here? L and M. All right, hopefully now you have a good understanding about how to determine if lines are parallel. All right, so let's look at question number 5. So in question number 5, what's true about those two measures of those angles? They have to be equal, right? Because it says that M is parallel to N. Now look, here is the symbol for parallel. That's the symbol for parallel. Is everybody with me? So does everybody agree those angles are equal? Now listen, we're going to really concentrate on our mental math here, guys. So hold on a minute before you say something. Give everybody a chance. So here we go. X equals. Now we just said those are equal. So mental math. Everybody should be able to look at that and say X equals what? Everybody should be able to look at that and say X equals 20. I really don't want you doing the work, right? Because you're practicing. I'm moving the 2X over. I'm adding the 23, right? 23 and 17 is not that hard. It's 40. Then 40 divided by 2 is what? So X is equal to what? X is equal to 20. All right? X equals 20. Now, the next thing we want to talk about here is this. If I say X equals 20, the question says just find X. All right, but let's see if that works out. We're going to check our answer. If I plug 20 in, what do I get? For this right here, I get 57, correct? So that angle would be 57. So on the other angle, it better be what?
57.
It better be 57. All right, and it is. So we just kind of demonstrated that those two angles are congruent. If those two angles are congruent, then the lines are parallel. All right, now listen one more time because I see this going around, guys. I've always said I don't care about the food in here, but it can't be a distraction. All right, it can't be a distraction. Everybody eats their own snack. We're not sharing in here, all right, because that creates a distraction. All right? Now, moving on to the proof. Here we go for question number 6. Now, copy and complete the proof for Theorem 3-5. So, if 1 is congruent to 2, now, what theorem is that? 1 is congruent to 2. Yeah, so that would be the proof to the alternate exterior angle. Now, here's what happens every year on the test. I say prove Theorem 3.5, and then people write down, well, angle 1 is congruent to angle 2, therefore the lines are parallel because they're alternate interior or alternate exterior angles. Is that what I'm asking? I am not asking that. You are proving that theorem. You're proving that theorem. Is everybody with me? All right, that's what we're proving. We're not saying, well, those are congruent, therefore it's parallel. All right, so now we're going to kind of walk you through it because it's really simple. Really, really simple. It's telling us that angle 1 is congruent to angle 2. All right, is everybody with me? We're trying to prove that the lines are parallel. Right now, I can't say, well, they're alternate exterior angles, therefore they're congruent. After today, after this lesson, anytime you see alternate exterior angles are congruent, you can automatically say the lines are what? But because we haven't proved that, you can't say it yet. Everybody with me? So now we're proving it. So angle 1 is congruent to angle 2. Why is that?
Isn't it like the definition?
No. Angle 1 is congruent to angle 2 because it is given. So I'm going to mark angle 1 is congruent to angle 2. Now, somebody tell me why angle 2 is congruent to angle 3. That is the vertical angle theorem. Exactly. All vertical angles are congruent. We proved that. That is a theorem. Vertical angle theorem. All right? Now, why is 1 congruent to angle 3? That is the transitive property, because why? If 1 equals 2 and 2 equals 3, then 1 has to equal 3. Is everybody good with that? All right? So now they're asking if 1 is congruent, or now that angle 1 is congruent to angle 3, what can we say about the two parallel lines? They are parallel. But why are they parallel? Because the corresponding angles. That's kind of where I had a big problem with geometry. Can we really prove that corresponding angles are congruent? No, we accept it as true by observation. Is everybody with me on this? So now she's 100% correct. So we can now say that L is parallel to M, and we would say it's by the corresponding angle postulate. The corresponding angle postulate. So now are we allowed to see, every time we see alternate exterior angles, can we say the lines are parallel? Yes, we can. All right, because we just proved that that's true. All right, does anybody have any questions with that? All right. Again, very simple proof. All right, let's see what's going on next. I don't really care about these dumb little pictures that they have. All right, here we go. Let's take a look at question number 8. Given the following information, determine if any are parallel. State the postulate or theorem that justifies your answer. All right, so here we go, guys. Let's go ahead. I'm just going to go through these. 8. I want to look at 8. Angle 1 and angle 2. What two lines are parallel? R and S by corresponding angle. Now remember, I'm trying to help those of you guys who are struggling a little bit and want to make an A but try to B. So now's the time you got to get involved. You got to answer the questions. It's not doing any good for me to write down corresponding angles and you just write down that answer. You're supposed to say the answer before I tell you what the answer is. Or you're supposed to write the answer before I tell you what the answer is. Then you can determine how much you understand. All right? So now we're checking out question 2, or I'm sorry, angle 2 and angle 9. So angle 2 and angle 9. Alternate exterior angles and what lines? U and V. All right, here we go. I'm good. All right, so now let's check out angle 5 and angle 7. Alternate interior angles. Alternate interior angles. Now that I've discussed 5 and 7, I'm just going to highlight it again. There's 7 and there's 5. Those are the two angles. Those are alternate interior angles. So what lines would be parallel? R and S. All right, I feel like you're getting it. All right, let me check it out. As soon as we say something adds up to 180, we should automatically know that it's what? Supplementary. So if 7 is supplementary to 8, what are those angles called? Consecutive interior angles. And so what lines would be parallel? R and S. I'm happy with that.
Would that be a postulate?
No, that's a theorem. The only one that's a postulate is the what? Corresponding angle postulate. Everything else can be proven. Everything else can be proven. All right, is that good? All right. Did we talk about angle 3 and 6 yet? 3 and 6, those have to be consecutive interior and what lines? U and V. All right. Now, let's find angle 3 and angle 5. Come on, don't be shy. 3 and 5, what are those called? Say it. And then what lines would be parallel? Exactly correct. Very, very easy. Very simple. All right, now I'm talking about 4 and 5. Those are definitely corresponding. R and S. Again, like I said, I'm trying to get more people. Come on, guys. More people. Does anybody have any questions? Good for you. Good. Yes, what's a good 14? So I highlight angle 3 and angle 7. All right, so let me highlight 3 and... Uh-oh. Did I skip that one, right? Yeah, thank you. All right, let's look at 3 and 7. That's an important one. 3 and 7. Is there a relationship? I don't think there's a relationship. Do you agree? Does everybody agree? Because listen to me, and some kids get confused, so I'm trying to help you. Look, 3 would have to do something with this over here. Do you agree? Right? Or you would say 3 would have to do something with this guy over here. Does everybody see what I'm talking about? So there's no relationship. All right? These angles over here have nothing to do with these angles over here. Does everybody agree with me on that? So no, there is no relationship. I'm listening to you, Daniel. Yes, correct. Hey, very good question. Very good question. But listen to what I'm saying. Listen, very, very good question. So if 3 is congruent to 5 and 5 is congruent to 7, then everything's parallel. You're 100% correct. But that's not what they're telling me. I don't know that 3 is congruent to 5. You see what I'm saying, right? That's a very good question. Listen to what he's saying. He's saying it should work because we know that 3 is congruent to 5, and then 5 would be congruent to 7. Do you agree? The problem with that is it doesn't say that 3 is congruent to 5. It just says something about 3 and 7. You hear me on this now, right? Everybody understand that? Yes. All right? If it said 3 was congruent to 5, and it said that 5 was congruent to 7, then you could say 3 is congruent to 7. But we don't know that for certain. Right? I'm telling you guys, you got to listen to that question. That was a good one. Right? Hopefully you understood what I just said. All right? Now, we're kind of going to go fly through the next ones, unless there's a question on these. These are important.
For number 15, it's alternate angle, but...
Hold on. 15, I put a dot there, that's one. Okay. 4 and... Are you with me? Does that make sense? Yeah. 15 was correspond. All right, no, that's okay. Everything's good. Okay, 16 now. Everybody, we can just talk about this real quick because I'm going to let you do this later on your own because I don't feel like doing the algebra. Is everybody with me? What's true about those two angles? They have to be equal. Come on. What's true about 17? It equals 90. That's what you should be able to look at right away and say, yes? What about number 18? They're equal. Aren't they equal? Right? 21 plus 2x and x plus 84, I believe those are alternate interior angles. So they have to be equal. Walker, I'm not sure what you're confused about.
I'm just wondering what exactly we're doing. Like, are we finding x? Or
yes, finding x. Isn't that what the directions say? Yeah. Find x. All right, now, before I said this, before I found out if I was correct or not, well, because we're so great at algebra, we don't have to double check ourselves because we're always right. Right? Yeah, that's what I said. All right? So listen, for these, all right, it would be nice to say those are alternate exterior, these are corresponding, these are alternate interior angles. That's what they want you to justify. All right? Now, for question 19, you would say that's what? What?
I know. Consecutive.
Consecutive interior angles. And so those angles have to add up to what? Those angles add up to 180. All right. Number 20. Ooh. Now, is there a relationship there, really? No, we don't have a relationship exactly between 3x and 2x plus 45. However, we do know that they're what? Supplementary. We know they're supplementary because the consecutive interiors are supplementary, and these two are vertical. So we could say that 3x plus 2x plus 45 is equal to what? 180. Everybody happy with that explanation? All right? Oh, I don't know. All right. Let's take a look at 21 now. If I'm looking at 21. All right. Those are what? Yeah, they try to mess you up by throwing this line in here. All right. That line doesn't affect anything. Those are alternate exterior angles, and alternate exterior angles are what? They're equal. All right. So finish that up. All right. Now, I'm not interested in this right here, obviously. All right. But I am interested in question number 23. All right, so here we go. We're going to try to do this proof. Come on. Stay with me now. This is the hard part. All right, so it's copy and complete the proof of Theorem 3-6. That's not us. All right. Okay. So now, Theorem 3-6, I have no idea what Theorem 3-6 is. That's just saying that it's in Chapter 3. Is everybody with me? Now, it's telling me that angle 1 and 2 are supplementary, so that probably means I'm proving the what? I'm proving the what? What theorem? I'm proving the consecutive interior angle theorem. That's what we're doing. And once I establish the theorem, I've proven the theorem, you now are going to be able to say anytime consecutive interior angles are supplementary, then the lines are parallel. That's what we're shooting for. But right now I can't say that. I have to show that. All right, so let's see what they're asking. First, number 1. A is what? Yeah, 1 and 2 are supplementary. That is obviously the given. Come on, focus. Yes, that's what you're doing. All right, focus with me. Now, it says, if 2 angles are supplementary, then they form a what? Linear pair. All right? Now, honestly, I prefer this because I don't think it's this way in your book, but we used to call it a linear pair postulate. All right? That's what I want you to say. And the linear pair postulate just simply says if two angles are supplementary, then they form a linear pair. All right? And that the linear pair, the angles add up to what? The angles add up to 180. All right, bless you. All right? So now that we know that angle 2 and angle 3 form a linear pair, what do you think the next line would be? Someone want to help me out?
1 plus 2 1 plus 2 equals 2 plus 2.
Yeah, but we haven't really said that yet. We haven't really said that.
2 is congruent.
I think it would be, we don't know that 2 is congruent to 3, but we do know that angle what? 1 is congruent to angle. Oh, wait a minute. No. Hold up a second, because I did make. Yes, it's hard for me to admit that. All right, so right off the bat, we said that angle 1 and angle 2 are supplementary. All right. Now we said angle 2 and 3 form a linear pair, so we'd have to say what? Angle 1 plus, oh, I'm sorry, not angle 1, but angle 2. Yes. Angle 2 plus angle 3 add up to 180. Angle 2 plus angle 3 is equal to 180 degrees. Yeah. Right? That was, definition of supplementary. All right. And up here, I'm going to say angle 1 and angle 2 are supplementary. All right.
See how they equal these substitution.
What are we substituting?
Because 1 plus 2 in the given is 180.
Hey, so here is what the rule is here, guys. Here's what the rule is. Now, something if two angles are supplementary to two of the other angles, then, well, let me just write it out just to review with you. All right, so here we go. So angle 1 and 2. So here's angle 1 and here's angle 2. And then over here, I have angle 2 and angle 3. All right, does everybody agree? Those are both supplementary, right? So angle 2 and angle 2 is in both of them. So if you have supplementary angles and you have two congruent angles in here, then the other two angles must be what? The other two angles must be congruent. All right? No, we would just say there's something we just write down. Supplements of congruent angles are what? Congruent. Supplements of congruent angles are congruent. Now, just let me make sure, because I kind of messed that up at the beginning. So here we go. Let me look up here, and I want to make sure you understand what I'm saying. Supplements of congruent angles. Angle 2, all right, those are congruent. You with me? So the supplements of those must also be what? Congruent. So angle 1 has to be congruent to angle 3. All right? And I'm trying to get you to see that. So double check if you didn't see that. So we would say supplements of congruent angles are what? Are congruent. Supplements of congruent angles are congruent. Now that we've shown that angle 1 is congruent to angle 3, now we can say that the lines are what? Lines L and M are parallel because they are what? Angle 1 is what? Relationship to 3. Corresponding. So we could say the corresponding angle postulate. Everybody with me on this now? What?
Can you put like interior or exterior?
For what? Now, listen to me. So I want to look up here now real quick. Just look back here. I'm talking about angle 1 and angle 3. What is the relationship there? Yeah, not alternate interior. I'm not sure
Oh, it's the alternate.
you with me on that, right?
So whenever it's like a corresponding angle, they should have interior.
Right. All right. All right, so there's that proof. All right. Now, listen, I don't really care about 24. All right. So your job tonight is to try to figure out the proof for 25, 26, 27, and 28. Try to do those proofs. And then just go back quickly and do the algebra. Hold on, let me see. Did I forget? Oh, wait a minute. Yes. Listen to me. 33 through 35 are kind of like the SAT problems. All right, I definitely need you. And honestly, they're not that hard anyway. All right? They're not that hard anyway. All right, so 33 through 35.
So do we have to write like the whole proof out?
Yeah, that's what you're trying to do. All right, you're trying to write the proof on 25, 26, 27, and 28.
But not 33.
No, you're just solving it. All right, get to work. Lots of work.
Mr. Strong.
Page 2. Wait,